First come, first serve is the simplest CPU scheduling algorithm, and it is non-preemptive in nature. The processes are executed in order they arrive in the ready queue. Once a process starts executing, it runs until completion before the next process begins. It is very easy to understand and implement, and it is very suitable for batch systems. So, the convoy effect of this process is long processes at the start of the queue. It can delay the shorter processes, and it can causes inefficiency in CPU utilization. And it has a very high waiting time for shorter processes. And this is best suited for scenarios where simplicity is prioritized over efficiency. Okay, the characteristic of this process is first, the processes are executed according to the order of their arrival. The algorithm has a high waiting time because of the convoy effect. The performance of the algorithm is poor due to high traffic of waiting time due to delays and reduced CPU efficiency. The scheduling algorithm is really straightforward and simple to implement rather than other scheduling algorithms. Okay, the advantage of FCFS, it is the simplest scheduling algorithm, easy to understand and implement. Processes are executed in the order they arrive, making it straightforward to manage. The algorithm is easy to code and requires minimal complexity, so it is ideal for basic use cases. The disadvantage is first, once a process starts, it runs to completion, which means no other process can interrupt even if it's more urgent. Processes have to wait for all earlier processes to finish, which can result in long delays for shorter processes. The algorithm struggles with efficiency, especially when longer processes block the queue, delaying anything else. Poor performance. If a long process arrives first, shorter processes are forced to wait, making the system less responsive. So, the input for this experiment is first the number of processes and each processor's arrival time. The output is start time, finish time, waiting time, and turnaround time for each process, and average waiting time, and average turnaround time. So, the step is very simple: sort processes by arrival time, calculate sort processes by arrival time, and then calculate the start time, the finish time, the waiting time, the turnaround time based on the formula given, and compute average waiting time and average turnaround time by averaging the respective values for all processes.
Hi, my name is Arifa Zulaika, and today I'm going to talk about the coding of first come first serve. First, we talk about the process class. The section defines the process object to hold the relevant data for each process. The process class encapsulates key details such as process ID, arrival time, burst time, start time, finish time, wait time, and turnaround time. It providing a structured way to manage data for each process. In FCFS scheduling, the processes are executed in the exact order they arrive, making it simple but prone to the convoy effect, where the short processes wait behind the long ones. This class structure helps simulate and display scheduling results efficiently. Then we have the reading user input. This section prompts the user to enter the number of processes and their respective details. First, the program prompts the user to input the number of processes, which define the size of the process array. This step ensures the program dynamically adjusts the handle any number of processes specified by the user. Next, the program collects the details for each process, including the arrival time and burst time. The arrival time represents when the process enters the queue, while the burst time indicates the time required for execution. These values are used to create and store process objects, preparing the data for the scheduling and further computation tasks. The third one is sorting process by arrival time. This section arranges the processes in the order they arrive. The processes are arranged in ascending order based on their arrival time using a sorting function. This step ensures that the processes are executed in the exact order they arrive, adhering to the fundamental principle of FCFS scheduling. Sorting guarantees accurate simulation and calculation of waiting and turnaround time. For the scheduling and calculating metrics, this is where we start to calculate the start time, finish time, wait time, and turnaround time for each process. For the start time, the process begins when the CPU becomes available, calculated as the maximum of the current time or the process arrival time. Finish time, determined by adding the burst time to the start time. For the wait time, the time spent waiting in the queue before execution, calculated as the difference between start time and arrival time. And last one, turnaround time, the total time from arrival to completion calculated as finish time minus the arrival time. This program keeps track of the total wait time and turnaround time to calculate the average later. The current time is updated after each process to reflect when the CPU will be free for the next process. This structured approach ensures the accurate calculation and visualization of scheduling result. After we are done, enter the input. This section calculates and displays the average waiting time and turnaround time. For an average waiting time, it represents the average duration a process spends waiting in the queue before execution. For the average turnaround time, it indicates the average total time from the process arrival to its completion. By dividing the accumulated wait and turnaround time by the total number of processes, the program provides valuable insight to the efficiency scheduling algorithm, helping the assess system performance. After we are done with the whole coding, the scanner needs to close to prevent the resource leaks. The purpose is to release the system resource tied to the scanner after completing user input operation properly, then ensures the clean and efficient program execution by avoiding unnecessary resource consumption. It is a good practice in Java to maintain the application stability and resource management.
So hi, my name is Afrina Izati binti Shahrudin. So I will continue with the sample input and output. So we use 5 processes for the sample input. So for the first process is process 3 because the arrival time is 1 and then the burst time is 4. And then after we run the coding, we got that the turnaround time is 4. And then for the next process is process 1. The arrival time is 2, the burst time is 3 and the turnaround time is 6. And then process 4. The arrival time is 3, the burst time is also 3, and then the turnaround time is 8. And then the next process is process 5. The arrival time is 5, the burst time is 2, and then the turnaround time is 8. And then the last process is process 2 because the arrival time is 6, and then the burst time is 5, and the turnaround time is 12. And after we run the coding, also we got that the average for the waiting time is 4.2, and then the average for turnaround time is 7.6. So the next one is the Gantt chart. So after we get the input and output, we use it to produce the Gantt chart. So the next one is the challenges that we found when we try to run the first come first serve coding. So the first one is sorting processes by arrival time. So the problem is that we found that the trouble with unsorted input, which has caused issues when the process were not in the right order but based on the arrival time. So as a team, we decided to use the arrays.sort in Java with a custom comparator to ensure that the processes were always sorted correctly by their arrival time. And then the second challenges is handling the edge cases. So we encountered the problems when there were processes with identical arrival times or a burst time of 0, which leading to calculation errors. So to handle this, we added the additional checks for these edge cases. So each one of us review the logic to ensure that the calculations will still work correctly, even with unusual inputs. And then the last challenges that we found is accurate timing calculations. So the main issue was to ensure that the waiting and turnaround times were calculated correctly, especially when the current time exceeded the process arrival time. So for the solution, we used math.max to make sure that the start time was calculated accurately even when the process arrived after the current time. So this approach helped to keep the timing calculations on track. So that's all from us. Thank you.